Good morning, everyone, and welcome to the third CUTLER webinar. My name is Panos Kostakos, and I'm working at the Center for Ubiquitous Computing at the University of Oulu in Finland. I'm really excited to be here with you this morning and talk about the challenges, tools, and methods involved in using big data for policymaking in the context of the CUTLER project. Let's go over some housekeeping matters before we start. As you may know, the webinar is live streamed in Facebook, so you can follow this link and you can watch the webinar in Facebook. You can share it with your friends and you can like. Also, the webinar is recorded and the video will be later on available in the CUTLER website, but also in YouTube and Facebook page. The presentation also and the slides and the material that will be used will also be shared in the CUTLER website. Please mute your microphones and make sure your cameras are turned off. And also questions will be answered at the end of the presentation. So if you have any questions, feel free to either raise your virtual hand or you can post the question in the chat. Also, I would like, in case you are not familiar with the webinar series of the CUTLER project, I would like very briefly to guide you to the webpage of the project. And on the top, you can see this link to the webinar webpage. And if you click, you will be able to access all the information with regards to the series and the focus, the rationale of the series, and also the target audience, dates, and links to existing presentations, or rather past presentations. So everything from this presentation today will be shared in the CUTLER webpage. Now, with regards to the agenda, today the presentation is divided into two parts. In the first part, I will go through very briefly the documentation of the CUTLER project, and we have a number of deliverables which amount to about 600 of technical pages. I'm not going to go through that, but all the information that I will share today with you can also be accessed in these deliverables. We also have the project wiki, which is not publicly accessed, but all of the content of the wiki can be seen and can be accessed through the public deliverables. And also, I'm going to guide you through the GitHub repo, and this is publicly accessed. So if you have, if you want to go through the codes and the crawlers that we have been developing, you will be able to do that through our GitHub account. So this is the first part. The second part, I would like to do a hands-on demo. So we're going to build from scratch a dashboard that visualizes data from Twitter. And to do that, I'm going to use Twitter, Elasticsearch, and Kibana. So the learning outcomes of this webinar is to increase knowledge of the tools needed for populating a data lake. So if you have a smart city project, you probably need to have a data lake or any other kind of database to store your data. And one of the goals here is to kind of, at least in the beginner's level, try to highlight how this is done. A second objective is to improve skills to collect and harmonize data from diverse data sources. In a smart city project, we're dealing with many data sources that can come from different angles, including social data, economic data, and data about the environment. So today I'm going to briefly touch on the bottlenecks in collecting this kind of data, and also how CUTLER managed to overcome these bottlenecks. And finally, the final learning outcome is to enhance your ability to overcome the challenges in collecting the data. So this is about data crawling. I'm going to briefly talk about what kind of crawlers we have developed and how these crawlers can scale up and scale out to include other data sources in the future. The target audience is both non-technical experts and developers. For non-technical experts, I think the demo is quite, let's say, not very advanced. So I had in mind non-experts, policymakers, or people who don't have background in computer science, so people who are not developers. And with this in mind, I tried to develop a demo that will kind of be easy to comprehend. And also for developers who have good skills in programming, but maybe they haven't tried to use, let's say, Elasticsearch or Kibana for dashboards, then I think this is an audience that can also benefit from this presentation. Let's start with documentation. So just to introduce the subject, in case you are not familiar with the CUTLER project, the goal of the project is to shift policymaking from intuition-based to evidence-based. So what do we mean by intuition-based? So intuition-based is basically what is kind of happening throughout the world. We want to do something as policymakers, let's say to build a road or better to build a park. And we believe that building a park in this location will bring out the best outcomes for our communities. Now, this is based on intuition and on beliefs. And evidence-based is based on knowledge. So by adopting an evidence-based policymaking approach, at the end of the day, we know that building a park in a specific location will bring about the best outcomes. Now, to achieve this, the CUTLER project has developed this circular approach where here we start, let's say, with a data collection. The data collection then is sent to a data analytics module. And from there on, we can engage with policymakers through a process that was developed in CUTLER to use this data and to integrate their data into their decision making. Now, once this is done, once this policy making is done and the decision is kind of been driven by the data, it feeds back into the data. So here we have, let's say, a chicken and egg problem. It's not that the data creates the policy or the policy creates the data. Once you adopt the model and you let it run over a few iterations, then the policy making and the data becomes one. Now, within this paradigm, it's quite straightforward to understand that the data sources are quite large. So here in this figure, I'm presenting the data, let's say, unique data attributes that we have collected in the CUTLER project. And starting from the left-hand side, we start with the pilots. And so a pilot, let's say, it's one municipality dealing with one or two policies. So we start from there, and then we segregate the data in different kind of environmental, social, and economic data. And from there on, we try to identify, let's say, who is the data owner, and for each data owner, what kind of attributes we have. And then we end up with the actual data point or the value that is being measured. Now, this is for CUTLER, but you can think that if you want to scale up to more smart city actors, more data, and more policies, then very soon you will have massive amounts of data, and there is no way to do anything with this data because everything becomes complex. Then we start posing very interesting questions about how do we collect the data, how do we crawl the data, and what kind of mechanisms can we use to scale up to more actors, but also scale out to more policies? How can we make sure that the data can be used in other systems? So this is the question of interoperability. How do we index this kind of data, and what kind of mappings and schema we use, what kind of data models we use? So these are all open questions that we try to address in the project. Now, the first step for kind of simplifying and organizing this information is to have a data catalog. So in the project, very early on, we established a data catalog. And here you see a screenshot from the project wiki. So the catalog is basically organized per location. So we have 5 locations, 5 pilots, and also we have a parent node which includes data that is applicable to all pilots. Now, once you're here, let's say you can click in one of the pilots, in this case in Thessaloniki, and then you will have all the data sources indexed and organized with regards to the context. So environment, social, and economic data. For each source, then you can even drill in, and we have documented anything that can be related to the specific data source. So this here, this is information that data scientists and developers can use in order to make sure that they can use the data, they can use it in conjunction with other data. With regards to the crawlers, we have developed a large number of crawlers. And of course, in smart cities and smart city projects, you have different data, but also you have different ways where this data has been stored. So you can have a PDF file, you can have Excel files. So our crawlers can scrap data from static documents. It can be an Excel file that you have somewhere, or it can be a crawler that is scheduled to scrap web pages, APIs. And so we kind of try to address all the scenarios where a smart city actor has data in different modalities and in different databases, and then we crawl this data. And actually, after crawling the data, we store the data in JSON and CSV within this HDFS, and this then gives access to more actors to reuse the data and to visualize the data and to actually gain some benefits and added value. Now, all the crawlers are available in our GitHub, and soon enough, I'm going to navigate in our GitHub, and I will just walk you around. But before doing that, I would like to talk a bit about the high-level architecture. So how do we collect the data? Well, this schema here represents a kind of simplified version of the CUTLER architecture. On the left-hand side, we have all the clients that in some way or another, they provide data. So we can have sensors, we can have crawlers, analyzers. And through Kafka, we pass this data into this big data storage and processing, which is mainly Elasticsearch and HDFS. This is for storing the data. Once the data is stored, then services like Kibana can access the data and then provide visualizations. If you're a developer, you can navigate and you can read our deliverables from work package 3, and there you will find tables that document all the crawlers. And this is quite nice because you have links to the GitHub, so you can immediately find the source code for the crawler, but you also have metadata and descriptions. So you can find out what kind of libraries we're using, parameters, descriptions, and what kind of outputs the crawler is expected to produce. Now, let's very briefly go to our GitHub. This is, sorry. So let's say this is the main page. So all the crawlers are organized in the folders, and each folder is dealing with the specific data type or data source. We have README files that you can read to understand how the GitHub, how our repo is organized. So for instance, here, if I go and click on environmental data, so the folder contains crawlers and also README file, and you can see what we're doing here. It's a direct, this is here a direct link to a crawler, a description, and then some other features. And if you drill in into the folder directory, you will find other crawlers provided by our partners. Okay, so this is more or less everything about documentation. Of course, keep in mind that it's many pages, it's technical documentation, so I don't want to bore you with that. So what I'm going to do next is I'm going to start demo. So we're going to start a demo that at the end of the session will give us a dashboard like the one you see on your screen. So we're going to use Twitter data. We're going to crawl tweets about COVID-19, and then we're going to extract the sentiment, the tokens, and other information that we will want to visualize in a dashboard. So I have already prepared a markdown document with all the code and some steps that you can follow to replicate this demo. And I'm going to share this later on along with my slides. So here we're going to follow 7 simple steps to develop this dashboard. And again, this is a very basic dashboard. It's mainly for testing and development. It's really far away from being a dashboard that can be deployed in a production environment. And the reason why I decided to do this demo is to first enable non-expert users to understand how this technology works in a very fundamental and basic way, but also to highlight the challenges and bottlenecks that these kind of solutions entail. And to my view, CUTLER has managed to overcome most, if not all, of the challenges that we currently have with regards to collecting data and then visualizing data for a specific purpose. So that is to say, for policymaking. All right, so let's head to the demo. So here we have a few objectives. So what we're going to do is we're going to use Tweepy, which is a library in Python, to collect streaming tweets. Then on these tweets, we're going to perform some, let's say, machine learning operations using natural language processing. Then once we have used these machine learning operations, we're going to store the data. We're going to index the data into Elasticsearch. I'm going to show you very basic queries. So how do you search the data once indexed in Elasticsearch? And then I'm going to start building the dashboards in Kibana. All right, so we have to, so basically the demo is comprised of 7 steps. Here, the first step, of course, is always try to download and install the servers. So with these commands, we download and install Elasticsearch. Now, I've done this beforehand, so I didn't want you to just wait and see me downloading stuff. So I will just head to my folder. I think it's this. Yeah, all right. So here I have a folder called servers. And in that folder, I've already downloaded Elasticsearch. So now what I'm going to do is I'm going to navigate into the Elasticsearch folder. And I'll go to the bin folder, binaries, and then I will start Elasticsearch. So by the way, if this doesn't work, because it's a live demo, I think what I'm going to do is that I will just stop the presentation, and then later on I will just upload an offline version of the demo. But it seems that the server is working. So okay, so now we have Elasticsearch running on our local machine. Let's try to test. So we do a curl. So. All right, so we see that Elasticsearch is running in localhost, I don't see any problems. So that's great. Actually, another way of verifying that Elasticsearch is running is you go to your browser and you again go to localhost and port 9200. All right. So everything seems to be working. So let's go to the next step, which is Kibana. So now we're going to download Kibana and then run Kibana so that all the data that we store in Elasticsearch can be accessed by the Kibana server. So I'll make a new page, go back. I already have Kibana here, so I'll just, there is no need to download. I will just cd into the folder, cd into bin, and then I'll start Kibana server. Now let's see. It's a bit slow, but okay, it's working. Well, it takes a few seconds. All right. So let's verify that Kibana is up and running. So like Elasticsearch, we can always go to our browser and try to see if we can access Kibana, but it seems that we're running into problems. Oh, all right. Okay, so kind of stuck for a bit. Yeah, okay, so let's try to refresh. Okay, so now it's up and running. So step one was to install Elasticsearch, install and run Elasticsearch. Step two was to install and run Kibana. And now we need, of course, a few libraries. So we're going to use Tweepy, which is a library that enables you to grab tweets from Twitter, and also TextBlob, which is a natural language processing library. So we're going to use TextBlob to do sentiment analysis on our tweets. And then we're going to use Elasticsearch to index the data using Python. So I think I already have these libraries here on my computer. So if I do a pip list, I will see what kind of, if I have the libraries, okay, TextBlob, I have, Elasticsearch, I have, and Tweepy. So Tweepy I have. Perfect. Okay, so let's do a kind of very simple demo, or let's test the TextBlob library. So I'm going to use Python and import TextBlob. Okay, and then from TextBlob, so I'm going to import the TextBlob class. And then what we can do is we can say, okay, let's say text equals to TextBlob, and then I will pass a string. So I'll say, okay, this is a great tutorial on Kibana. I love it. So clearly this will have some kind of positive sentiment, and let's see what we can get out of it. So we're going to do a text sentiment. Right, so we do text sentiment on the string, and we get polarity and subjectivity. So this is kind of the data that we can also use later on the tweets. We can also use, let's say, text words. So with text words, we can tokenize the words. And we do that here in order to create, let's say, word clouds in Kibana dashboard. And tags. So text tags will give us the part of speech tags. Because we might want to know, okay, are there adjectives in a tweet? So adjectives usually entail sentiment, let's say, or verbs entail action. So maybe we want to find out kind of part of speech tags and try to figure out how we can use these to visualize the data or to analyze the data. And this is quite basic. It goes on and on and on the things you can do. You can write your own scripts, your own programs to extract locations or to extract events and topics and anything you want. So that was very quick rundown on how to use the text blob. So let's move to step 4. So step 4 is you have to register in Twitter to register your application before you can access any kind of data from Twitter. And we're not going to do that, but there are many tutorials online and they can teach you how to access data from Twitter and how you can get these API keys and so on and so forth. Now, once you have the keys, so let me turn this. Okay, so once you have the keys from Twitter, you need to kind of pass these credentials into your scripts. So it's going to be kind of a fake example here because I don't want to share my credentials. You'll have to kind of have a script saying, okay, these are my credentials. And then your main script will talk to this script and will give you access to Twitter. This is kind of technical, but a more simple example, let's say, okay, we have access to Twitter. What kind of data do we get out of Twitter? And as data scientists, as smart city officials, we would like to know if the data is in a clean format and if we can use it. So here I have a kind of very basic script. I hope you can see the text. If not, just text me in the chat. So if you see the text, so this is a script that will basically try to listen to Twitter stream. So Twitter stream is data that is being developed real time. So it's not historical data. And I'm going to listen to the stream and I'm going to just grab the tweets based on the keywords. So I'm going to run this now, and what you will see in the screen is just the real-time tweets that mention COVID-19. So I hope it works. Oh, okay, nice. So now we have access to streaming tweets. I'll stop this process. So you can see that these are large blocks of text. And usually a tweet is one line, it's not longer than one line. But when you listen to the API, you get all this metadata along with a single tweet. And just to visualize it and to make it a bit more pretty, I'm going to prettify the JSON. So again, I start listening to tweets and I stop it quite early just to kind of demonstrate how does an actual tweet looks like. Of course, when the tweet is collected from the API. Okay, so here we have data about the user. So if the user is using GPS or any other tools to identify location, then their location and their data will be visible here to us. And all other kind of metadata and information about the user, the friends, the followers. So that's that. I mean, that was just a very simple example to demonstrate the scope and the depth of the data that we can get from Twitter. So that was step 5. Okay, we've run the test. Just a second. All right. So so here with this script, I mean, we managed to get the data, but the data stays in our monitor. We don't do anything with this. So what we're going to do in the next step is to listen to data about COVID-19 and then store the data into Elasticsearch. So Elasticsearch is, let's say, for the time being, let's say it's a database. Although some people will have kind of reservations on how to call Elasticsearch. But for the time being, we call it a database. So now we're going to stream data from Twitter and then pass it on to Elasticsearch. And I'll just very briefly go through the script. So this is the crawler, let's say, that will listen to the tweets. So here in the first block, we import all the libraries, and then we open connection with Elasticsearch. Now our Elasticsearch is running, so that's good. So we're going to listen to tweets, and so let's say this pipeline will also use the machine learning or natural language processing operations that I demonstrated earlier. So we're going to grab a tweet, we're going to pass it to text blob, and then we're going to get polarity. We're going to do some very basic transformations on the polarity and the sentiment of the tweet. And then we're going to store the data into an index. So this index will be called sentiment. And the index will have different fields, such as author, so who is the author of the tweet, the date, the actual message, post tags, so this is the grammar, so we want to see adjectives and verbs and nouns. We're going to also store tokens. We're going to use the tokens for building the word clouds. And of course, polarity, subjectivity, and sentiment. So this is all the data that we're going to collect from the Twitter and store it into Elasticsearch. All right, so this is the crawler. Okay, so I guess we are kind of ready to see if the script works. It should work. I've tested yesterday and this morning, but you never know. So let's see. All right, so it's working. So what is happening here, we collect the tweets, we do all this processing real time, and then we index the tweets, or we index the data into Elasticsearch. Yeah, so let's check, let it run, and then we check here if actually Elasticsearch is collecting any data. So I'm going to use a few commands on the browser. Yeah, so basically, let's check if the index indices. So if our index is stored, no, it's not that. So I guess it's this. All right. Yeah. Okay, so we have an index with. Okay, so here, actually I cheated a bit because yesterday I was running the crawler and I wanted to make sure that I have data in the database, otherwise the visualization will not look nice. So I have over 25,000 tweets. So most of these tweets is from yesterday, from last night, let's say. But here we're collecting more tweets. So if I was to refresh this, most likely this number will go up or not. It takes some time for Elasticsearch to kind of update the numbers. Let's check. I'm going to stop the crawler because if I refresh, maybe I will crash the server. But all right, so it doesn't update. Never mind. So what we can do next is to maybe have a look at the data. No, we already seen the data. Maybe I'll go to Elasticsearch, to Kibana. So here in Kibana, this is a nice interface. We can start using a few of the tools. So the dev tools will allow us to write queries to kind of have a look into the index. So I'll do the get sentiment. So this is kind of very basic query. So the get sentiment will give you something called mapping. So the mapping is basically a way for the server to parse the data or to index the data in a way that you as a user think that will give you the most value. So let's say if you have dates, you need to use mapping to convert the data from string to date, or from string to keywords. So Elasticsearch is quite nice because it does this automatically. So we didn't have to use mappings to when we index the data. But I think colleagues in the future webinars, they will go through this concept of mappings in more details. Okay, so maybe we can run this query and we'll get to see, okay, one file, let's say, or one one hit in the, we get only one hit from the Elasticsearch index. And the data that we managed to port into the index includes the date, so it's author, the date, message. So we get the whole message, and then we have this data from the machine learning operations, and the tokens, polarity, subjectivity, and sentiment. Okay, so that's good enough. I mean, we have kind of basic data to build a dashboard. We can also explore this search feature of Elasticsearch. So earlier I say that Elasticsearch is a kind of database, but also Elasticsearch allows you to search your data in really fast ways. So here we're going to just search for the query Paris. So within our data, so the tweets that we've been collecting, let's find tweets that mention Paris. And there you can have this kind of all the messages that contain the keyword Paris. We can also do a more kind of complicated query because we have all these part of speech tags. So we can also search for Paris plus an adjective. So we only get tweets that contain Paris where an adjective is also present in the same tweet. So this is kind of more complex, let's say, search queries. All right, so I guess now I finished with all the basic porting and updating and testing. So we can go ahead and start building the dashboards. So the script is not working. I don't mind, so I'll just, okay. So the first step when you build a dashboard is you have to identify the index and the pattern that will be used from Kibana, that will be used in Kibana. And in this case, we just, we have one index. So we're just going ahead and select the index. And here you can kind of see, okay, what kind of data do you have? Now, this is quite important because in our case, we only have, let's say, dates, text, and some numbers, floats, let's say, for the sentiment. And here you can see the type of data you have. And if you scale up and you include more data sources, then this becomes quite fast. It can become a mess. And you need to make sure that your data follow a specific data model, or the specific data type is the correct one. So here you can kind of see your mapping, what kind of data so how the mapping converted your data, and what kind of data you end up having in your index. Now, in the case of tweeters, it's quite straightforward. We actually don't do any changes. Even for the date here, we're going to use the string data, which is kind of incorrect way of doing it. But Kibana is kind of very flexible with that regards. So we're not going to change any of the data types. All right, so then we can just go to dashboard and select create dashboard, or wow, that's a different, sorry, I think I need to check. I think it's the index from last night. So very quickly, I'll check my crawler. Yeah, that was sentiment one, so that's strange. Okay, oh, that's fine. Oh yeah, so I got it. So last night I was also testing this the dashboard, and I created a dashboard, I guess, which was called sentiment one, or some kind of figure which was called sentiment one. So here, we just created a new dashboard, and in the dashboard, I'm going to start adding the figures. So of course, if you've seen the webinar last week, then you will know that creating the dashboards, it's actually the output of this decision-making engine, or the decision-making process that we have within the CUTLER project. But so here, just for this demo, we don't need to kind of elaborate on the decision-making process. We just say we want to have dashboards, and so let's kind of build this dashboard. So I guess first I'm going to have a counter. So I want to see, okay, how many tweets do I have in the database? All right, so in the counter, I'm going to add buckets. And then histogram, I think. No, actually, we don't need any of this. So this is actually the counter of the tweets. We don't need to mess around with this here. So if I click update, it doesn't. So yeah, sorry. I'll click update. It's updated. And then I'll just click save, and I will put count. I will add this to the dashboard. Yeah, okay, great. So the first figure has been added into the dashboard. Let's go for now the good stuff. Let's say sentiment. Let's try to visualize sentiment. I'll just go here, create a new figure, a new visualization, and I'm going to use a pie chart. From pie chart, I'm going to select the sentiment index. And this is a kind of donut style. We don't want donut, we want the whole pie. And I'm going to enable show labels. Okay, so this again the count. So I'm going to select, okay, what kind of data do I want to visualize? And I want to visualize, I'll go for the terms first. So sentiment keyword. Let's see what this does. Okay, so yeah. So now that's a pie visualizing the positive, negative, and neutral tweets. And I think that's quite all right. So I'll just click save, and I'll put sentiment. All right, so second figure is there. I'll do some word clouds maybe. So now we can see the tweets, we can see the sentiment, but some keywords will help us understand what is being discussed in Twitter. So I will do a bucket terms, and I'm going to use the tokens. So that's why we tokenized the tweet in the first stage. We can start doing aggregations on the tokens, on the keywords. I'm not sure this is the right way of doing it, but if I click, all right, so okay, we have a cloud of, let's say, 16 keywords. I'm going to expand this to 200. Yeah, it doesn't look nice, but I guess it will work for the time being. So tags, I will call it tags 1. So that's the cloud. Maybe we can add authors. So let's see, like, who is tweeting. Yeah, that's a nice visualization to have. How we do that, we go again, tag cloud, the sentiment index. And from there, we go to buckets and tags. And I'm going to aggregate on terms. And in the field, I'm going to just select the author keyword. And I would like to see, let's say, the 50 top authors. There you go. Okay, so that's a nice cloud. We can kind of visualize who is tweeting. I will click save. I will click author, type author, save. And then, all right. So maybe, okay. So we have the count, we have the sentiment, some of the keywords, we have the authors. What else we can do? Maybe on subjectivity. Yeah, I can do one subjectivity to see if the tweet is subjective or objective. So I'll just click here, another pie chart, sentiment. So labels, okay. So I guess for subjectivity, we're going to use a histogram, although I'm not sure. Let's do that. Update. All right, okay. Okay, so here we can see tweets which are subjective and objective. Of course, this is not a nice visualization because subjectivity is a range from 0 to 1, if I'm not mistaken. Let's try. Yeah, so it's from 0 to 1. But at least here we can at least find out, okay, who is 1, so who is, I guess, really subjective. Anyway, okay, so that will do for the time being. Yeah. So that's that. We have sentiment, subjectivity, count, tweets. What we can also do, and this will be the last visualization, the last figure, is to play around with a part of speech tags. So the verbs, the adjectives, and the nouns, and all these nice features that we can include in the dashboard. And how we do that, again, another pie chart. And I'm going to make a bucket, and the bucket this time will include terms. And I'm going to aggregate on the terms field. Yeah, so it's the post tags. And maybe we can include the top 12. Let's update. Nice. Okay, so now we have a pie chart, and we can kind of observe the part of speech tags which are included in our database, in our index. I will call it POS, part of speech tags. Oh, okay, so this is, I get an error because yesterday I was playing around with this. Okay, so we have that. I still have about 10 minutes, so maybe what I'm going to do is change a bit the shape here. I'll bring this up. This is quite... Here, yeah. Maybe one table with the tweets so we can actually see the tweets. So we go for the data table, the sentiment index, buckets, split rows, terms, and I think is this one here. Let's get, let's say the 30. All right, so we get the tweets. Of course, most of the tweets will be retweets because here we rank based on number of counts. But that's quite nice. So now we have this table. Maybe I will change the options here. I'm going to add, let's say I want to get to see 30 rows. There you go. I'm going to save that, and I'm going to save it as a text. Oh, yeah. All right, so now we have kind of everything we need to monitor COVID-19 on Twitter. So what you can do here, so one good thing with Kibana is that you can play around with these figures. So these figures are interactive, let's say. So if you want to update and see only the negative tweets, you can just come here, you click negative, and then everything in the dashboard changes. So now you just see the negative tweets. Let's say here we see many retweets and many kind of words that they don't convey any meaning, like HTTPS and stuff like that. So perhaps we can use this post tag visualization to exclude, let's say, RT. So we want to exclude retweets for some reason. And we can just come here and click that. So now we see only retweets, but we can change that if we go to the settings and we give is not retweet. So now we get all the negative tweets which are not retweets. Okay, so this is how this is done. And something else that we can do is we can start the script. So earlier I kind of tested the script. I know that it's working. And now I'm going to start the crawler. So the crawler will crawl data, I will pass it to Elasticsearch, and then from Elasticsearch, we're going to visualize it in Kibana. And hopefully, if this works, everything will be kind of updated real time. Oh no, sorry, I just have to, okay, so nothing is changing here. And the reason is that I haven't, I need to change the frequency in which this figure changes. So here it's off, so it doesn't update. I'm going to change the refresh rate and let's say make it, I'll try maybe, yeah, I'll try 1 second. It might crash. Save. Okay, so now, is it changing? Okay, so now it's changing. So every second we collect tweets and we pass these tweets into Elasticsearch and Kibana, and we see that the figures are changing all the time. real time every second. Yeah, so clearly here we're not going to see drastic changes because, yeah, it's kind of sentiment. So the sentiment kind of, it forms throughout time. So here we see how the count changes because we get more tweets in the database. Some of the keywords might change, and maybe authors, but I'm not sure about the authors. Okay, so this is actually kind of, it brings me to the end of the presentation. I will just stop the crawler because it might crash my computer, and I'll stop the refresh rate. So stop. Yeah. Okay. So that's it. So going back to CUTLER, so the point of this demo was to kind of navigate you through a very basic implementation of a dashboard, but also find the bottlenecks and the problems. And of course, the demo has many, many bottlenecks. So first one, it was nice to have a dashboard on my computer, but no one can access this dashboard except me or maybe someone else in my local network. Therefore, you need to scale up. And if you scale up, you also need to consider that things break. So Elasticsearch is a great tool, but if you leave a crawler crawling data, maybe in a few hours, it just crashes and you lose all your data. So you need to scale up into kind of a cluster format. You need to have servers that can be accessed by anyone, or like the service provided can be accessed by anyone, and can have different, let's say, features that will make your system and solution robust. So the first one, let's say, is the major bottleneck is make a network or a cluster that is robust and saves your data and protects your data and keeps your data secure, encrypted, so to avoid any kind of scenarios where you lose all your data. Encryption and security is also important. So in my local installation, there is no security, there is no encryption. So that's a bottleneck that we try to address in a production environment. Kibana, at this stage, so in my local installation, there are no users. So you want to have users and policymakers. And again, if you go to the webinar last week, then you will understand that policymakers need to have access to a decision-making engine, and all this will be linked together. So you need to have users, you need to make sure that there is security and there is encryption between communications. Also, mappings, I briefly elaborated on the mappings. So I'm using the default setting in Elasticsearch where you don't have to describe the mapping. But when you scale out and you scale up, then you need to make sure that you have mappings to guarantee that the data is actually, the data type actually reflects the type of data that you want to visualize and you want to analyze. So if it's a date, it has to be marked as a date. If it's text, it has to be marked as a text. And now I'm getting a question about the data collection. Yes. Yes. Another issue is, okay, if you have more than one smart city actor, let's say you have 10 smart cities or 50 or 100. Now, how do you make sure that everything scales up into a way that people can actually use the service? How can you make sure that the data that you're collecting can be used by other services and not just by you? And maybe I can go back again to one of my slides. because I've seen there's a question about the data collection. So here, so I think one of the, let's say, beyond the state of the art or novelty of the project is the ability to actually to use Kafka and to use this consumer produce and schema to collect the data, to pass the data to Elasticsearch and Hadoop and to do all the analytics, but also to enable others to reuse the data in the future. So this is one of the, let's say, novelties and future proofs of the project. The data can be reused, they can scale up, they can include more clients, they can include more sensors, and they can really add value into the policy making and decision making process. And with that, I think I'll conclude. I'm already 5 minutes after 11 or after 12. So if you have any questions, please kind of feel free. Either ask me or raise your hand or type in the chat. Thank you. Okay, it seems that we don't have any questions. You can always drop me an email, and if you watch this in the future, maybe I can also go back to my first slide. So this is my email. Feel free to ask me any questions you have, or feel free to ask for clarifications. If something wasn't clear, I'll do my best to kind of address your question. Okay, I don't. So, Filarete, do you want to wait a bit more, or do you want to conclude the session? All right. So thank you again for coming here, and I hope you enjoyed the tutorial. And if you have any further questions, don't hesitate to contact me. Thank you.